Hello, everyone. I am Professor Julio Rezende. Today we are having a presentation about main station on Mars. Just confirming, today is March 16th, 2022. Okay. It's one of the presentations during the mission 109. Also, we have friends from Poland and India in this mission, and I from Brazil. And everybody are welcome to watch this presentation that we are releasing in YouTube channel too, the Habitat Market YouTube channel. I hope that everybody likes this presentation about one of the facilities of the station on Mars. In this case, we have here in this slide, we have, it's possible to see different possible stages about Mars settlement. We have a first stage, like a moment of survivability with a minimal crew, permanent presence, critical hardware only. Mid-term of sustainability, when we have larger crews, additional less critical hardware, and operational moment with bigger crew and complete equipments and hardware, dealing with all criticalities. In this case, we are imagining that the station that we are proposing for Mars exploration is a midterm station with a crew around 28 astronauts. Okay. But in the first moment, Mars will be receiving the first models of a station, and we can imagine that in the first moments, one of the first stages to build this habitat is supposed to be the main station. And this is about my presentation. The main station is supposed to be like the first model, like in just a few astronauts. And from main station presents all the capabilities to survivability of the crew, and bring support to build the other six sectors connected to the main station. In this case, it's possible to see the idea about how would be the station on Mars. Okay. And in this case, we'll be talking about the main station, one of these facilities. The first moment of my presentation is about internal design. In this case, we received a collaboration of a Brazilian architecture student. Her name is Mariana Guerra. And Mariana Guerra proposed two different collaborations. One is not be a circular shape, but hexagonal shape, because the hexagonal shape would be more easy to connect different components of the habitat. And also, the other contribution from her is not only one model, but three models connected. In this case, the three models were named as alpha, beta, and gamma model. Okay, and the alpha model is for resting and relaxing. The beta model is for entertainment and dining, and the gamma model is to operate as a control center and to support operations for entire station. Okay. Also, in the alpha model, we have the bedrooms, the bunks, the study rooms, and the restrooms. In the beta model, it presents the kitchen, the dining room, and living room, entertainment area. And the gamma model presents the mission control, training, and research room. In the alpha model, it's presenting in the three levels, 14 bunks. Okay. Also, these bunks, 5 bunks in the second and third floor, and 4 bunks in the ground floor. Also, 2 bathrooms and 1 study area. Also, it's possible to see The proposal about we have some plants aboard some regions is to evaluate their quality, also brings nature to space habitats. Also this is connected to psychological well-being, less stress and more health and well-being. The possibility of vegetables production bring practicity and easiness to prepare fresh meal according to the concept of pick and eat. And also the plants aboard would be helpful to meditation. Here is possible to see a concept of a dormitory. It's very similar to the hostels around the world, with where we have some bunks in the hostels and shared rooms. Also, we have in the main station in this model alpha model, a lot of terabytes of music, books, and movies. Okay, also sometimes also possible physical books and digital books. The second model, the beta model, is a model for entertainment. In this case, in the ground floor, we have the kitchen, dining room, the second floor, living room, and the third floor, the gym. It's possible to see the like a swimming pool, a small swimming pool for. It also is a proposal of Michael Lowry in the Kitely environment. It's a virtual world, and he designed it virtual environment and proposed like a living room like this with music instruments. Also, the kitchen and the robotic kitchen. This is a kind of robot developed by Molly Robotics. This is just a robot available to buy. It's this robot presents a technology of image learning. In this case, it's possible, the machine is possible to read the labels of the products and use these products to prepare the meal. Also understand the instructions in a YouTube video to prepare the meal. In this case, this is supposed to be very interesting for future space exploration, also bring support to the astronauts in the kitchen. A concept of dining room, also a concept of gym. Okay, and also we can imagine it's very important the practice of exercise by the astronauts. In the third model, the gamma model. The gamma model presents in the ground floor, the research room, the training room, and the mission control. Also, it's possible to see the evolution of the panels from the vehicles, space vehicles. In this case, the Apollo missions, the shuttle missions, just presenting some small screens. In the Dragon capsule from the SpaceX, presenting bigger screens, and also operational systems like like the systems that we have today. In this case, we can imagine systems like multitasking resources, and from these screens to be used to control many activities in the station and many operations. Also imagine a dashboard to control the entire station. And this dashboard is connected to greenhouse, to power station, to health center, and to sanitation. Here you have more details about how this would be operating. In this case, the main station is we are connected with greenhouse, sometimes using a system, sometimes using a direct communication with the chief of greenhouse. And the cooker from in the main station, he has or she has a great interest to know from the greenhouse chief what are the vegetables available to produce a meal. In this case, the greenhouse chief would inform that look, today we have tomato or we have carrots, or there is a like lettuce is available. We are harvesting these vegetables today, is available to you in the kitchen to prepare the meal. In this case, the most part of the communications is to understand this. Also to understand some levels of operation too. In the contact with health, we need to understand how is the health condition of each astronaut, because on Mars, the astronauts we supposed to be exposed to great radiation levels, and these would bring some health problems, health difficulties to the astronauts, and we need to understand and follow how is the health condition of astronauts. It's very important we follow this, because if you identify some deteriorations in terms of health conditions, you need to identify the possible interventions to reestablish the health conditions of astronauts. Also, contacting with the power station, need to understand how is the capacity of energy generation to supply the station. If we are generating enough energy using the solar power system, also the kilopower nuclear fission generation. You need also to understand how is the consumption of energy in the station. Sometimes it's possible to have some systems and some parts of the station consuming more energy than normal. And you need to understand these reasons, why some parts of the station is consuming more energy than necessary, or if you are comparing month by month, and if we are presenting great difference, you need to understand some reasons about, and also the police station needs to present some guidelines to how to consume less energy in our operations. And from a station, we need to control the operation of sanitation tool, conversating with the sanitation chief. And you need to understand about the water generation, clean water generation, and also air generation, oxygen generation. We need to understand if all systems are operating well, if they are in a good conditions, or if there are some threats in terms of oxygen generation and water generation, because the sanitation center is like the heart of the station. If you have some problems in terms of oxygen generation and water generation, the station would collapse, okay? And because it's not possible to live without oxygen and water. So in this case, it's very important, the operation of sanitation center. From a station, also we are following some external conditions like weather, temperature, lightning, wind, and dust storm. And also if you have good conditions to develop the extravehicular activities, okay? Also, if it's happening, the extravehicular activities, what are the levels of oxygen and energy in the spacesuits? Also, in this model, we have the research room to develop analysis of spacesuit garment and soil analysis and other exams. Now we are talking about the second part of my presentation about applied technologies. We can see a lot of machines operating in the kitchens, like the oven, the fridge. Entertainment area will be using virtual reality headsets, also the spy hydro message, also disco lightning. In the control center, like communication technologies, antennas and sensors and computers. Also possible resource to generate in situ or transported from Earth. We believe that almost everything will be transported from Earth. Some utensils would be 3D printed on Mars. And also part of the food will be produced in Mars greenhouse. The third moment of this presentation is about management. In this case, we imagine 4 astronauts in the main station. In this case, the commander, executive chief, chef, and general assistant. The commander is supposed to be someone with multidisciplinary background or someone from management or industrial engineering with a high capacity of leadership, intercultural competency, a high personal resilience. And some duties are control the extravehicular activities, also propose routines and operational protocols, provide guidance to avoid the risks, conduct educational activities, preparation for EVAs, also coordinate daily communication routines with NASA, ESA, ISRO, and other space agencies from Earth, also with mission control centers, sometimes communication with the other facilities, with entire crew, and sometimes the communication with some specific astronauts in the station, okay? The second position is the executive chief would be an engineer, an information technology specialist, or psychologist. Some duties are monitor our operations, keep all facilities running, monitor routine maintenance, organize specific operation and responsible astronauts, coordinate training, organize specific operation and responsible astronauts, stimulate self-sustainability when each one is observing self-organization, self-maintenance, self-fixing, alerting other astronauts. And the third positions, maybe one of most interesting positions in the station, is the chef. The chef is supposed to be a cooker, a cuisine chef, a nutritionist, a gastronomer, and some duties are define the menu, the meals, the food logistics, perform food preparation, waste disposal, cleaning, organization, maintenance, and repair procedures in the kitchen. Also assess the team's nutritional requirements, plan the availability of food, and define feed shifts. Here in this slide, it's possible to see a photo of the character of Neo from the movie The Matrix, also interpreted by Keanu Reeves. And this figure was presented by Dr. Cyan Proctor in one of our virtual missions. And now she is an astronaut. She participated in the mission of Inspiration 4 in September 2021. And she was one of our virtual members in our mission. And during her presentation about this topic, she presented this photo, this image, to bring some interesting discussion. And she was mentioned that in this photo, Neil is presenting expression related to consider the meals very boring, okay? And because all days is oat milk, all days oat milk every day. And he's not happy with this because it's not presenting diverse food, okay? In this case, Dr. Cyan Proctor was remembered that the responsible for meal preparation in a station need to think about very diverse and creative and also colorful and inspiring food to let the astronauts happy, okay? Because also the moment of the meal, it's a very interesting social moment when everybody should be happy, you know, and having a good moment. And we consider this contribution of Dr. Cyan Proctor very interesting. Also, in this case, in in-person missions of Habitat Market, we are trying to also follow this guideline, also trying to bring interesting meals for the astronauts, okay? And some duties, okay, that I just mentioned. And also, we can see here more two photos. The first photos is pre-prepared meal of freeze-dried food transported from Earth to astronauts. Also, this food is transported in plastic bags when the hot water is infused inside these plastic bags, and when these meals, freeze-dried food, is in contact with hot water, the food recover the properties presented on Earth. In this case, is very interesting. We imagine that we can't live without on Mars in the first moment, in the first years, without meals and food transported from Earth. But we need each day combine the pre-prepared food transported from Earth with some food prepared on Mars and produced in our greenhouse. In this case, this last photo is some food produced in Habitat Marte greenhouse. It's showing lettuce, basil, and pepper. And the last position from this facility is the assistant. It's supposed to be an engineer, an information technology technician, a psychologist, or an artist. These astronauts is supposed to emphasize the team's well-being, create interesting content to entertain the team, and deal with food management, support the chef, coordinate the organization of the dormitory, coordinate the gym, also manage laboratory tools, study routines, sample analysis, and psychological surveys with astronauts. Some topics of training of the astronauts, we imagine the necessity to develop new skills based on situations identified on Mars, new situations that we'll be living there. Also training about systems operation, about new technologies, about training about the positions and tests of each astronauts and simulations. Here we have some videos to train the astronauts, also entertain the crew. Videos in YouTube about the team's work and mental health, and also a lot of videos about music, okay? And about some resources to supply the operation. We imagine 1 kilo of solid food for to feed the astronauts, each astronaut. Also 4 liters of water to drink, more 2.5 liters of water to prepare the food, and more 2 liters to the bath. Is in this case, this quantity by day is in this case being necessary to multiply for the quantity of astronauts and quantity of days. Some guidelines to be provided to other facilities from main stations. From main station can provide guidelines about daily routines and schedule activities, health occupation, health environmental safety guidelines, how to maintain plants in specific space habitats, about harmony and collaboration, how to let astronauts comfortable about to be in space, stimulus for cooperation, innovation, creativity, well-being through interesting content to entertain the team, stimulate self-sustainability when each one observes self-organization, self-maintenance, self-fixation, and alerting others. Now, this is one of last part of my presentation is about the protocols. About protocols, you can imagine some specific protocols operating the main station, like protocols to encourage the harmony and good relationships, protocols to deal with stress, to organize the room, to plan maintenance, for food production, for infrastructure maintenance, to save water and to save energy. Also, we can imagine some protocols of safety and health related to hygiene, about wearable data collection, about health data from saliva, blood, feces, and urine, protocols to deal with psychological balancing and emergencies, protocols and simulations to deal with accidents. These are some protocols related to safety and health. About some protocols for entertainment, we would like to celebrate the birthdays of astronauts in the stations, also organize like a party, have a happy day during the week. Also celebration days like Diwali and Holi from India, Dia de los Muertos from Mexico, Carnival from Brazil, and Halloween from United States, Christmas, New Year's, other dates like St. Patrick's Day, depends of the crew. from the countries. You'd like to identify what are the national days that would be celebrated on March 2. In this case, we would be organizing the spa day and using board games or video games, also practicing yoga and workouts, and also mindfulness meditation. Also would have suggestions in terms of terabytes of music, movies, and books. This would be a concept of vertical garden. And for vertical garden, we have a proposal of protocol for cultivation, protocol for maintenance and detection of adjustments and management of the plants, also food collection protocol, protocol for rotation, disposal of the plant, best time for irrigation, male, female flower pollination, and plant cycle. About 3D printing, we have here the first two photos, a printer using clay, okay, to build ceramics utensils. In this case, we imagine that it's supposed to be interesting for Mars because we would be using like the regolith. Yeah, we know that this regolith from Mars is supposed to be prepared like a homogeneous formulation without dirty parts to prepare the mud, prepare the clay to be transformed in a material to print ceramic materials. This would be very interesting if possible see this possibility in the next 20 years, I believe. Also a plastic 3D printer. This is also a photo of a commercial clay 3D printer. If it's possible to see, there is a transparent plastic tube when the clay is inserted inside, and there is a nozzle of 5 millimeters nozzle, and this is very interesting technology to print some ceramic materials. And the last photo is a metal powder 3D printer that is supposed to be interesting for Mars if we develop in the next years some mining technology on Mars. About 3D printing, we imagine the necessity to have a lot of computer files about the CAD project. This will define what possible things to be printed. Also imagine a product degradation recycling protocol. In this case, if you are imagining that we'll be using a lot of plastic bags to transport the meals for the astronauts, we are suggesting that all plastic bags is supposed to be using a single plastic. And in this case, the plastic bags is supposed to be grounded, okay, to a further refining into smaller particles in a blender. These small particles are melted and extruded into a plastic filament for 3D printing. And this this filament from recycled plastic is supposed to be used in an additive manufacturing process, creating new objects to be used on Mars. And now about the spin-offs, we just be developing on Earth some technologies for sleep. In this case, it's a kind of machine that is draining the blood from superior part of the body to the lower part of the body, because without gravity, great part of the blood would be going to the head, and also bring some healthy difficulties, health problems to the astronauts. In this case, a technology like this would be draining the blood to lower parts and also bringing more health conditions, okay, to the astronauts. The second photo is related to technologies for food production. This is a equipment called VEGI, aboard of the International Space Station, also producing some big peppers, as you can see here. And there's also other technologies that's available. Also, you can see some technologies for learning, like using the virtual reality headsets. This would be useful for the astronauts, and also technologies for water saving. This is an environmental control life support system. I believe this is a urine processor assembly. This equipment was transported from Earth to International Space Station and avoid the transport of water to International Space Station, because in the first moment of International Space Station, all water consumed uh, was necessary to be transported from Earth. And since this equipment was installed in International Space Station, 75% of the water becomes to be recycled from the urine of astronauts. Other interesting point is the possibility to recover the salt also in the urine and other mineral elements. Also, technologies for energy saving, and it's a kind of uh, a floor when you are walking is generating energy, and the last thought is a grinder to also for recycling. Some guidelines to be applied to our daily lives on Earth are related to health, environmental, and safety guidelines, mental well-being, health occupancy, daily routines and guidelines, and recycling mindset. In this case, we imagine that the astronauts in the main station would be doing lectures and lives from Mars to Earth, explaining how they are living, how they are trying to be healthy, and also how the sustainability is important to them on Mars that would be applied to Earth. In the last part of my presentation is about what are the sustainable development goals impacted from main station. We can see that the operation of main station presents impacts in terms of discussion of good health. Also, we are providing new skills and new competencies from main stations related to quality education. Also, we are promoting the gender equality. In this case is important. We have a balance between women and men working the main station. If it's 4 persons, would be 2 male astronauts and 2 female astronauts. Also, it's very important for us the also clean water, and also save water and save energy. The goal 12 is related to recycling. The goal 16 is related to management, and the goal 17 is related to partnerships. In this case, we imagine that the main station is supposed to receive astronauts from many different nationalities, okay? And these are my profile in Twitter, Julio FD Rezende, and my profile in Instagram, Julio Rezende. And thanks so much for your attention. Okay. And now I am stopping my recording. And thanks so much.